So what's the point of us being able to factor a polynomial? Well, just like our quadratics, again, we could find our x-intercepts are zeros. Same idea here. So I have this equation, y equals x plus 2 times x minus 1 times x plus 3. And I want to find the zeros of this function and then graph. So this won't be a specific graph. It won't be exact of what this polynomial function would look like, but it'll give us some of the ballpark information. First, to find our zeros, just like with our quadratics, we want to find when each factor equals 0. So x plus 2 equals 0 when x is negative 2. X minus 1 equals 0 when x is 1. And x plus 3 equals 0 when x is negative 3. So this polynomial function has zeros at x equals negative 2, 1, and negative 3. And that's what we are going to start by graphing. Zero at negative 2, positive 1, and negative 3. All right, so there's a lot more to a graph than just this. What all do we need to include? When we're doing one of these graph, sketch, whatever you want to call them, okay, here's what I want you to include. I want you to include the zeros, the y-intercept, and also show the correct end behavior. It's whatever our end is doing. So we found our zeros. Let's find our y-intercept next. I need to figure out when is my graph going to cross the y-axis. Well, and whenever that happens, doesn't matter where you are on the y-axis, your x value is 0. So this point's 0, 1, 0, 2, 0, 3. Okay, to find my y-intercept, remember we can take that 0 value and plug it in for x. Plug 0 in for x, and that gives me 0 plus 2 times 0 minus 1 times 0 plus 3, which is 2 times negative 1 times positive 3. And 2 times negative 1 is negative 2 times 3, negative 6. So my y-intercept is negative 6 here. Right here. Last thing we have to include is our end behavior. And don't forget that end behavior is determined by the degree of our polynomial function. So imagine here, we don't flat out see all of our terms listed out, but imagine that we were trying to multiply all of this. If I multiplied all three binomials here, I would end up with x times x times x. I would end up with a degree of 3 because I'd have x to the third somewhere. Okay, and that degree of 3 means my ends go opposite directions. So this far left end is going to go down. This far right end is going to go up. We have some other things happening in the middle, but knowing my y-intercept is here, we can kind of fill in our missing pieces. So go down. Right here, this is an x-intercept, so we have to cross the x-axis here, and at some point we turn back around. And now this is a pretty loose sketch because I don't know how high this goes. For all I know, maybe our function really goes down a little bit farther in this little section of our graph, but this gives us a pretty good idea with some of our key features here where our x-intercepts, our y-intercept, and our end behavior is.